All right, so the next thing we're going to talk about is the change in enthalpy. And the change in enthalpy variable is this delta H. It's still measured in joules or kilojoules. Unit is still joules or kilojoules. Again, could be dealing with calories, but we're going to use the SI, the joules. But again, really it's dealing with heat again. Change in enthalpy can be considered as heat. I am so just brushing a little bit of the surface, and I don't want to confuse anyone, but change in enthalpy, basically by definition, is the measure of the total energy of a thermodynamic system. The measure of the total energy of a thermodynamic system. So since it's energy, we can talk about it as heat. The formula is not going to be this like Q formula. That's another type of thing. And notice that the variable is a little bit different. For our purposes, just take a look at how it works with an equation. So say we have this equation right here. Okay, and I sure hope everyone knows this this equation. This is glucose reacting with water. Glucose reacting water, with oxygen to produce carbon dioxide and water. Obviously, this is respiration. It's oxygen with glucose, burning of glucose to produce carbon dioxide and water. Now, what this basically says is this. The coefficients tells us how many moles of each of these reactants or products respectively. So we would have 1 mole of glucose, 6 moles of oxygen, 6 moles of carbon dioxide, and 6 moles of water. When we did the whole moles calculations, conversions, when you went like say moles of one to moles of another, you use these with these coefficients to convert from one to the other. It's the same exact situation here. So if this reaction takes place, if you have exactly 1 mole of glucose with 1 mole of oxygen, 6 moles of oxygen, you would produce 6 moles of carbon dioxide and 6 moles of water. There would be this amount of heat to 2,803 kilojoules, and I want you to know that it is released. And the way that we can tell that this is heat released is the negative sign, okay? It's an exothermic reaction, okay? So I could ask 3 things just looking at it. Is heat released or absorbed? It's released. Why? Because of the negative sign. Is it an endo or exothermic reaction? It's an exo because an exo is released and it's a negative delta H. And this would be getting hotter. This is a reaction that would be warm. Okay? So with 1 mole, 6 moles, 6 moles, 6 moles, you get that amount of heat released. Now, if you had 2 moles of this and 12 moles of oxygen and 12 moles of carbon dioxide and 12 moles, basically what you're saying is you're doubling the equation. You would also double delta H. So whatever the math is on that, you would have in this case negative 5606 kilojoules. So there would be negative 5,606 kilojoules released. Okay? So what happens when you're asked a question about this? Well, here's the question. Let me erase this so we can see it. I'll erase it all. Here's a simple mathematical word problem. It says, well, what happens if you have 44.4 grams of oxygen? How much heat transfer? And again, notice I also ask, am I not moving around enough? My light's turned off. If you have 44.4 grams of oxygen, how much heat transfer? Also, is it released or absorbed, exo, endothermic? Well, here's how you would solve this. You've got 44.4 grams of O2. Well, how many moles of O2 would we have? Because if we know we have 6 moles, then that's how much is released. If we don't have 6 moles, well then we would have a different amount released. So, let me grab a different color. Let's go to that green again. X line, grams of O2, moles O2. The number for moles is always 1. Grams, we look it up on the periodic table, is 32. So 44.4 divided by 32 is 1.38 moles of O2. So we don't have 6, which means we don't have that much heat released. But how do we know how to do it? How do we know how much we have? Well, X line. Notice I'm just going to put my labels again. I'm given moles. I'm going to put that on the bottom. Kilojoules is on top because I want to know how much heat transfer. The negative 2803, what's given, goes on the top, and that amount is for 6 moles. So notice my X line has that, just it's like saying per, negative 2803 kilojoules per 6 moles. If this would have been glucose I was asking here, then it would have been a 1 in the bottom. So basically we put whatever coefficient you have in the bottom and whatever is the delta H given in the top. Do a little bit of math, multiply that by 2803, hit equals on your calculator, divide by 6, and you get negative 644.7 kilojoules. So that amount of heat transfer, negative 644.7 kilojoules. Also, the question is asked, is this released or absorbed? It's released because of that negative sign, and it's also exothermic. All right, so that's a change in enthalpy formula calculations. We're going to be doing labs with this type of stuff, but in our class at least, but that's kind of the math behind it.